Good morning. I'm Ham4Ham. Today I'm going to talk about software programming, some of the tools I use, some of the what to do's, what not to do's, and basically how to go about it, which you may or may not learn in a university, and as I have learned over the years. So the first thing I'm going to talk about is the tools that I generally use to do the tasks that I used to do. And the first thing is the compiler I use. I choose to use the Embarcadero C++ Builder compiler for Windows. It can compile for Windows 32, Windows 64, and lately they've added iOS, Android, and the other output options to this. I use this because it's what I've used over all the many years. And this is not a paid endorsement. All these tools are just what I use to get the job done that I want to do. Right now I'm working on some software on the side for the amateur radio community, which is an antenna modeling software. So I use this as my compiler platform, which builds into Windows 32 and Windows 64. The next thing I use is Dreamweaver. I use Dreamweaver for the website. For my input, I do PHP programming, database programming, and I choose to use Dreamweaver. For my revision control system, I choose to use a program called Perforce. What this does, it allows me to check in and out documents, and what that means is if you've done any programming at all, you must use a revision control system. All these documents, it keeps the old ones and new ones in the database. You could see the differences between them, and it keeps a running history. And if you branch off multiple versions or have a problem with the version you're working on, you look at this and you can go back and you don't have to mess with things. And I'll discuss more about that shortly. And the website. For the website, I'm using Mantis. It's a bug tracking software. If you make software, you must have a bug tracking system. This allows you to get into the system. It allows users to track what's going on. And the key to good software development is good project management. You must have good project management when you're doing your software. And I'll show a little bit more how this works in a little bit here. Give me 1 second and I will be right back here. Okay, my apologies for that. I'm using Google Chrome as my separate browser and I hadn't logged into it and I just wanted to log into it. So the most important part of this is the Mantis bug tracker. Now this allows me to track what's going on in the software project that I'm working on, and it allows other users to indicate what they are looking for. And most of the time a project manager is going to handle this. If you're doing it by yourself, you got to keep track of what's going on. Mantis in particular gives you different views. You can see what's unresolved, what's been reported, what you've resolved, and what's been unassigned. Then as an admin, you have also the entire issue list, including the calendar date, who it's been assigned to, what's been working on. A user can report an issue. They have to create a username and password. Then they can report an issue to you. You'll get an email. It indicates what they're seeing. And they have access to most of these pages. They can view, they can report an issue. They can see the roadmap. The roadmap shows what version is being worked on, what trouble has been reported, and where it is. Basically, it gives you a progress bar, and it tells you the scheduled release date for the next release. So this is a key feature of doing any programming, is you must have these two tools. You must have some kind of bug tracking system, and you must have a software revision control system. Once you have these, you're pretty much set to go. Now I'll get back a little bit into the compiler, and then I'll move on to Dreamweaver for web. This software gives you different views. And most of the time on YouTube or something like that, if somebody's showing you something, it's just a test nothing program. This is a public project for amateur radio, and it will be released to the public. So what's here will eventually be shown, and if it's a new feature, it's already disseminated to the public, and most of the public knows about it already. So it doesn't matter in this case, and it gives you a good idea of what you could really do with the software. Now when you start out, you just create a new project, and you're going to get a form. On this form, you have a toolkit on the bottom right side, which has all your Windows controls. And very much like Microsoft's Visual C, you have all these toolkits. The advantage of why I use Embarcadero is the additional tools that you have available for database control, fast reports, which is basically a printable report system. Your form is a piece of 8x11, or if you're in the UK, your metric size paper. You're dropping the controls on there, you're running a query, and the query fills in the papered report with the information from the database, mostly automatically. You just have to program it how to go through the loop, and it does it automatically. So a lot of these tools already do the work for you, which makes it wonderful to use and easy to use. You got gestures now for all your touchscreen stuff, web services if you're making web programming. Additional Windows 10 controls are right here. Indie servers for all internet controls, talking TCP, IP, all that kind of stuff is in there. Already programmed. Indie is a public project as well. It's well documented on the web as to how to use it. T-charts. What you see here are T-charts. I take one of these, drop it in, pick the kind of series I want to use, and it comes up. So that's basically the controls that are there, that are available. So how do you go about doing it? Well, you basically drop the component you want on the form, and you start to program it to do something. And when it doesn't work right, you use a debugger. So what I wanted to do today is basically outline the tools I use and explain a little bit about how to go about it, and especially what to do if you have a big problem. Yesterday I had a particular problem. I wrote a bunch of code, and all of a sudden it started not working. And I played with it for a little bit to try and figure out what was wrong. And in the end, I'll tell you what was wrong, and I'll probably be able to go back to that in the revision control system. But basically, you set your code. I'm going to hit F9. It's going to compile it all in here, and we'll be off and running. There's a lot of other YouTube video content about how to program for specific instructions. I'm not really going to go into that today. I'm going to show the use of the debugger, how it comes up, how to set breakpoints, and some of the things that other people normally don't talk about. So let me just pick a good spot here in the code to set a breakpoint. This is for finding all the attached wires. We're going to stop in here. And the compiler allows you to, set a breakpoint on a code. I think everybody knows about that. That's not new. What's not talked about a lot, though, and I'm just going to make it run a model here real quick to get it into the code, is the CPU view, which I can get through the view menu, and I normally use the keyboard shortcut for this, so it is under debug windows, CPU, entire CPU. And this gives you the actual assembly code disassembly of all the instructions. Now, you don't need to know assembly language to program, but it is really helpful, especially when you got something going wrong and it's pointing to a wrong memory location, or you have a memory access violation, to see what happens. Another thing which is really important in programming is understanding how the stack works, how function calls are placed on the stack, how the memory pointers of the local function that you're running, in other words, this is my local function right here, all these variables, if it's pushed or used locally, get pushed onto the stack. And then the other thing is what to do if you have a big problem. Now, there is something called breakpoints. And I think everybody typically understands what a basic breakpoint is. Now, there are, however, memory breakpoints, which are very, very useful when you're having a problem. And you could get to those in the CPU view. Now, the problem is I don't use them very frequently. And I know it's in the debug. Here they are. Memory 1, memory 2. All right. So now this is, let's say, a memory view. And I'm running a function here which accesses a particular area of memory. Now let's just use F8 to step down here. And you can see we're trying to move into the registers. And this is where knowing assembly language, it gets to be really important, because these are the registers in the CPU itself. And it's telling it to move AX into CX. So let's let it do that. And you can see CX changed. Now, this is a particular memory location. So we can go to this address right here. And I'm just going to do a little bit more of this because I don't want to jump too off topic or in details for today. I believe I forgot the hex here. 1D0. So I've done programming for the last 30 years or so here. I've started on a Commodore VIC-20, and doing two things at once is always not the best for me, but here's a memory. So now it's moved that address location into RAX, and it's probably going to do something with it. But one of the important features is being able to set a breakpoint, and you could do it with the different compilers. Before I get too far off topic here, you could do it with the two compilers. So if you have a memory access problem, or you got corrupted memory, and you have an idea of what memory location went bad, unlike a normal breakpoint, a memory breakpoint it'll stop the program when it tries to read or write that particular address. And that's a key feature, a key understanding in trying to find trouble. So now let me go to the other tools, how I use them. There's plenty of videos on how to program, how to debug, but let me talk about why you use the revision control system some more. And then let me go to the main code, which is my form. And you can see all the revisions I've had here. There's 157 changes I made to this file over the development. And you could take a look at the revision graph, which will show you if you have different branches in the software, and they'll come off like trees here, off the main. Now, I only have one main because I'm still in the alpha development for this particular project. But let me go into what I did yesterday and why this was such a problem and why this was such a lifesaver to have this revision control system. What I'm going into is a time-lapse view. It gives me the ability to compare two revisions of the file. And now I just have to go back to the one that I had trouble with and find that particular one, which is probably some 50 or so ago. Anyway, this keeps track of all the changes I made to this file, and it works for any binary file and any text type file. It's most useful in the text type files because you could see the change and what number is associated with that change. And when you run into trouble, you can revert back, and instead of losing 3 hours, which I would have easily lost the other day figuring out what went wrong in my code, I lost a half hour because I went back to a previous version I did a half hour ago because I couldn't figure out what went wrong. And I will show you what went wrong here. And it was just a simple file corruption. For some reason, all the quotes had an extra space added. And I don't remember anything I did in the compiler that changed that particular coding. And I just have to look for the right revision here and see where it is, and I can show you. And instead of losing 3 or more hours of work, I only lost a small amount. Probably an easier way to do this is to look at the particular quote and area that I'm looking for. But you can see the red is all struck out. That's the areas that were changed. And all I have to do is find an example. See, I should have done this ahead of time, but hindsight is always 20/20. In any case, what it did is, and I do a lot of work saves with the revision control system, normally every 15 minutes, and I especially do one I'll show where, you know what, I have that, and that's even better example of, you can look at what's been submitted. So these are all the changes that I made and the reason in the description of why I did it. Do not make the mistake of doing this. Don't get in the habit of just writing updates and of what you would do. And why look for it, let me talk a little bit about why I chose to be a programmer. I already showed the tools that I did, why you would want to do this. Programming in the future is going to be something that is very commonplace. It's much easier, as we've seen over time, to change software than it is to change hardware. Hardware requires hardware updates. If you have a mistake in software, a bug, a feature doesn't work right, it can be changed, and now with the internet, it can be downloaded and updated. Tools all over the world, even cars like Tesla now, are using this, and if they have a problem, they can fix it on the fly. That's a key thing. You don't have to bring the car in. It doesn't have to get serviced. It downloads it from a satellite, and it gets brand new software. The tricky thing about software is all the possible combinations that can be used. And when you hit some of those combinations, they're bugs. You can't account for all the possible combinations that people can use in order to do or use your software. And probably in the Tesla case where they had that accident, what I understand about that particular case in the software is the camera wasn't able to see, and my guess is the software didn't know how to react to that or wasn't programmed at the time to do that, and I think they've made that change, but that's just Speculation on my part. I'm just using my experience to do that here. So here's my reversion back. Give me 1 second here. So here's my reversion back. Here I'm saying can't find the trouble. So now I know I'm starting to mark it more frequently because I know I've got some trouble somewhere. And I can't find it. And this change here is about 122. So if I go to change 122 here, and you can see how many changes I've made since then, which is good. You do use frequently your revision control system when you're making changes. When the power goes out, anything, electric drops, you want to have your changes. You don't want to have a lot of work you've done without a lot of documentation behind it. Another really important thing to software documentation is creating the documentation files that go with that. And normally you're going to be stuck on a project and you're going to be working very intensely on that project. This helps me later to make the documentation for what I was working on at the time with the list of my submissions here. So now I'm going to take a look at this time-lapse view here for this one here. 157, I know I'm going back to 122-ish. Where did I mark the trouble? Sudden trouble now. That's at change revision 258, but file 122. So between 122 or 120, a little bit before and a little bit after, you could see what happened and how I got out of it, because I never would have known. I don't remember doing anything that should have caused this in the compiler. It could have been a simple hard drive a problem or something going on in the Windows operating system or a compiler. And let's see the changes now. Let's look at them here, because I know let me go a little bit before here, right after the problem. So I'm reverting, can't find the trouble, and revert back. So we got 124 and 122. So I need 124 and 122. But I'm not sure if they cover this this usage in universities a lot. And another thing of what I'm seeing the revision control systems used more and more for now, even Word documents, group team sharing. If someone has a file on a network and you're accessing that network or that server, Word and other software will lock that from other people's use. Well, that's fine if you only have one person working on it. Or not fine, because you might not know that somebody else is working on that particular Word doc, maybe an instruction manual, other kind of engineering document. But here you can see. You can see here, quote, space. Never would have figured that. And there's other areas where this was in. I think it's 123 where I reverted it. And now we should see all the quote spaces where the mistake was. Now there's file naming mechanism in here, and when I created, I think what happened was when I was creating some Windows temporary files. Now I'm not seeing any changes. What happened here? That might have been the revision back itself. So. Excuse me. So here I'm using temporary file names, and you could see it added a space after the quote to every single quote, open quote I had in the program, and I wouldn't figure that out. All I knew is all of a sudden it didn't work. So with this, I was able to go back and fix the problem. And that's the importance of this. Instead of losing multiple hours of work not knowing what actually happened when I didn't intentionally create this change, it just happened. Sometimes things happen on the operating system and the file save goes wrong, or something happens in the compiler. When you're using a debugger in an operating system, it is right against and in front of the processor, and that's a hardware driver. And things can go wrong with hardware drivers, which affect the rest of the operating system. So I never would have been able to found this, and this saved me. I don't know how many hours of work. Yes, I lost, and I think in this case it was less, because the time I lost was much less. So now I know there's trouble. So here I know there's trouble. That's at 10:24 in the evening. And I'm talking about ripping up other code, and I don't know what happened. I did a big strip out, and then all of a sudden I noticed a problem. So I lost somewhere between these 2 hours of work. And instead of using more time to try and find the trouble, I was able to use the revision control system to revert back, where I reverted back to here or something like that, and go over again. I probably did it before the big strip out, or as soon as I noticed the trouble, I reverted the file back until it ran again properly. Then I branched it over and then kept going. And that's the use of that. So let me discuss a little bit Dreamweaver and why I like Dreamweaver. Dreamweaver has a lot of the stuff, much like Embarcadero does for C++ built in. There is a lot of the database stuff already in it, where you can drag and drop, and it does a lot of the work for you, including PHP security features when you're doing a page login, or that's all automatic. And then you could set up the navigation bar with Bootstrap, make it into a template, and the template copies over to each page. So you only have to if you change let's say the links, that's a template. Everything else gets changed over for you automatically because you based it on that template. Yes, you can do it as a PHP include file. I could have done it that way. It's easier to let the tools do the work. For some $20 a month, you could get Dreamweaver. If you use it a lot, it's well worth it. I believe getting the tools that you use a lot is very useful. It has synchronization. It does not. One of the features I would love to see in it is some kind of PHP debugging. And I do have access to a beta version. I think you can find a beta version on their site. I'm hoping they adding something like that, because I don't like having to debug in a different software. When I use my tools, like I use Embarcadero, everything is in one spot. And that's what you want. You don't want to be crawling between Winamp and different programs to debug and go back and forth. That's a pain in the neck. I want to work in the one tool and go from there. So that's basically it for today. These are the basic tools you need to be doing software. These are must-haves. Don't try and do it without it. I mean, Mantis, I get that with my web hosting automatically. It's free. You use it. You can have an issue. You can see what's going on in that particular issue, and it's just loading up the site here. It gives you categories, assignments. Most of the key things in doing proper programming is your documentation. A lot of people just like the program, don't document things very well, and then when you go back to it, you can't figure out what the heck was going on. So make sure you're commenting a lot in all your software. Explain what's going on. You may not be the only one that ends up using this. And certainly for this particular project, I had a lapse of 6 months in between. It was not easy to go back and look and figure out what I was doing at the time that I was doing it. But with the comments, it helps. You're explaining what's going on when you're going along. If you have variables, and this is a good example of what not to do. I have variables in the header file. I haven't explained what they're used for. You know, you should be marking everything. It'll save you time. Here I started marking some more, but all these, at least this structure should explain what it's for, and the variables should explain what it's for. You shouldn't have to guess. It should be very clear to everyone using it, and that's one of the keys to being a good programmer, is your documentation. Now, to be fair, yeah, it takes a lot of time to do the documentation. Sometimes it takes 3 times as long a time to do a documentation manual, and I do my manuals in a help file system, which creates a PDF. So basically, when this end document is done, it'll have all the variables in the class explained, and the functions, and they create hot links, and it tells you what it does and what it's used for in a PDF file. And that's a very useful tool too. But my tool is kind of outdated and not supported any longer, so I don't want to really discuss that. But I'm sure there's new ones out there. It embeds comments into the code with a special key, basically, that explains what it's doing for. So the comments are all written in the code as well, and it outputs the PDF file. So you have a cross-reference between the two. It's always important to have the cross-references and the good documentation. I hope people got a lot out of this video today, or get a lot out of it in the future. Let me just see. No comments. Okay, great. I know a lot of people don't really look at this stuff, but if you're going to do programming, yes, you should do it. Use the right tools. Don't try and be inexpensive about it. Get the right tools. A lot of companies will offer hobbyists the student price, or even something that they call a bootstrap price, which means I really don't have a lot of money, but I'd really like to do your software. If you talk to a salesperson for the company that you're looking at, they will work with you to get you what you need to do, even if it's under the typical corporation price, because a sale is better than no sale. And they know that, and they know the hobbyist or whomever is going to use it, maybe a beginner, someone going to university, even the student price may be too high. They will work with you. Just get a sales guy on the phone. He'll help you out. Hope everybody had a great time today and people get use out of this video in the future. Thank you very much.